Hey there! Let's look at one of the exercises from my course. So let me just begin by reading it to you. How many Norwegians are expected to have an IQ greater than 145? Assume that population size is 5 million and that the IQ is normally distributed with a mean of 100 and a standard deviation of 15. Use both a numeric and analytical approach. So in this case, the analytical approach is actually a lot easier than the numeric approach, which Monte Carlo simulation is. So we can expect, based on analytical approach, that there are 6,749.49 something number of individuals in Norway with an IQ greater of 145 based on these assumptions, which are outlined in the exercise text. And in this case, analytical approach is very easy to do, so there's actually no need to do a Monte Carlo simulation. And the reason for that is that an analytical approach is always, it gives a precise answer. It gives you the same answer no matter who runs the calculation. While the numeric approach will give a slightly different answer every time you run the simulation. And only on average would you expect it to be equal to the true value. But nevertheless, we have done a Monte Carlo simulation here, and as you can see, the outcome when I did the Monte Carlo simulation here is 6,749.34, and that is really close to the analytical approach. So as you can see, we can kind of get the same answer here. Not even one person in difference. So how did I get this number? Well, it's the average of 100 simulations. And in each simulation, I simulated 5 million Norwegians. So how did I do that? We can use Alt F11 to open up the VBA editor. And here you can see we made a subroutine. Sub is short for subroutine. Here we have the name of this Monte Carlo simulation. This Monte Carlo _ Norwegian IQ. That's the name of the subroutine. Then we do some changes here to Excel in order to optimize for speed. And the way we made the script here, we don't really actually need these settings here so much this time. Usually I kind of output the results directly in the worksheet, and that kind of is very slow and tedious. In that case, we would need this application setting changes. But in this case, not so much, but still, I just leave it in there. So most important here, when you change the calculations to manual, you should change it back to automatic and at the end of the script. Moving on here, I start out by deleting the previous content in the worksheet. So everything in column A, just delete it, get rid of it. Next there, I output in range A1 just a string, which you can see here. Frequency of IQ greater than 145, so nothing magical about that. Next, I have a set of parameters there. N is set equal to 100, and that is just how many simulations I want to do, or how many iterations in my simulation would be more precise to say. So 100 times I'm simulating the Norwegian population. And the population size is 5 million, as we specified in the question text. Next, the average value of IQ is assumed to be 100, which is pretty much always going to be the case, because we just define average IQ as 100. Then we have a standard deviation here of 15, again, just from the question text. Next here, we do the actual simulation. So we have two for loops wrapped inside of each other. The first for loop is just 100 different iterations, and within each iteration we simulate, or we have another for loop where we simulate each of the 5 million individuals in Norway. Counter here is just a variable that keeps track of how many Norwegians have an IQ greater than 145. So when I simulate each of these 5 million individuals, if I come across a person with an IQ sufficiently high, I will add that to the counter. So my main approach here is to use the universality of the uniform, which we talked about in a previous lecture. So basically I input a pseudo random number, which is between 0 and 1, into the quantile function of the normal distribution with the desired mean and standard deviation. So here you can see application.worksheet_function.norm_s_in. That is the quantile function, and the input it requires is this pseudo-random number, which is uniform between 0 and 1. And then I take this and multiply it with the desired standard deviation and add this desired average value. One problem with the script though is that the quantile function does not actually work when the pseudo-random number, which is the input here, is precisely equal to 0. It's gonna crash then, basically get an invalid output. So I have a do-while loop here. So I just pull a random number or pseudo-random number from this pseudo-random number generator, and if it's equal to 0, that means then I just try again. So we didn't come across this problem in the lecture because we're only doing like 100,000 iterations, for instance. The chances of getting a 0 then was pretty slim, but now we're doing it 5 million times multiplied by 100. So yeah, I'm gonna come across here a 0 in there, and that would crash the script. So we just need to make sure that the pseudo-random number is not precisely equal to 0. So that's what's happening here in this segment of the code. Next, if the IQ is greater than 45, well, then I add that to the counter. Counter is equal to counter plus 1. And finally, I just output the result of this iteration. And as you can see here in the worksheet, we have 100 of them. And on average, we get a value pretty close to the analytical approach. So that's the solution guide for this homework. I have nothing else to say. So good luck with the rest of the homework, I suppose. Yeah, good luck with the rest. This was the simple exercise. The rest is a lot more difficult.